Okay, so we are going to start this session. This session is all about scipy tutorial. Here you can see scientific Python. The introduction of this session is depending upon scientific Python, and we will be dealing with mathematical algorithms, their functions, NumPy extension of Python. Actually, it's a NumPy extension of Python, and most frequently used in data science and machine learning. Here we have high level commands, classes for manipulating visualization data, and additional benefits for this scipy on Python, right? So there is a clear trend in the data science and machine learning. Until unless you do not have the basic knowledge of this content, right? This scientific language, you cannot go for higher things, right? So what's the content cover? We are going to cover this. What we are going to cover. So let me make it first. Make it markdown and then copy. So we are going to cover basic polynomial condition, spatial function inside the Python. Then we will cover integration, linear algebra, Fourier transformation, interpolation, statistic, miscellaneous things. Others also, right? So first we are going to discuss this basic polynomial, right? What is the polynomial terms, right? So allow me to import NumPy, which is from the NumPy. I'm going to import this poly1d, right? This polynomial one dimensional module will be importing from my method, will be importing from my NumPy module, right? We have p as a symbol, and we will consist entire equation in this single variable, right? It will consist of all the variable, entire equation, not the variable but entire equation it will consist of, right? So I'll write poly1d. So inside poly1d I'm going to write 3 comma 6 comma 8, or you will write p. So you will find polynomial 1 this p, right? But if you write, let's say print, if you print p here, so you will find 3x square plus 6x plus 8, right? So let me open my whiteboard so that I can create that equation. So meanwhile we can perform another things. What other things we have? We have this one, print p asterisk p, right? So p asterisk p means 3x raised to power 2 plus 4x raised to power x plus 5 raised to power 2, right? So what's the p asterisk p? Here we have p is what? P is consisting of this equation, right? 3x square plus 6x, right? Now if you run this code, can you find this 9x square, 36x cube answer? What's this entire equation? So let me come on this whiteboard where we have p. This p is consisting of 3x square, right, plus 6x, we have next part 6x plus 8. We are going to initialize this equation, right? But when we talk about p asterisk p, so it's a multiply the same equation using the same part, right? So if you are going to select this one, so I'm going to select all the terms here, cut C and cut V. So I'll put it over here and will put multiplication sign in between, right? So here I'll put multiplication of these two equations. So this is the first p, and here I am in the second parenthesis I am having second p. So I'm going to multiply this p with the p itself. So if you multiply the first term 3x square into 3x square, so you will get this as a 9x raised to power 4, right? This would be for first term. Can you see this 9x to the power 4? And subsequently the terms will be there, right? Now we can find out the another print p, like another function with respect to p, where we have print of this value, and then let's say we have p2 is equal to, what's a p2 here? I'll explain in a couple of minutes. I'm having p2 in the place of this one, right? Then I'll have next equation, print p of 2, the value of p with respect to 2, and the value of p with respect to 3. So what would be the value of this one? And here I am having p 2 comma 3. All right, so let me run this code. Can you see? Okay, so do I have so maybe this is double quotes, and here I am having double quote. Let me run this code. Okay, so p2 and p3 is equal to p, oh, it's not allowed actually, p and then square bracket 2 comma 3. Inside the function, inside the tuple, we have this value. So can you see this is giving p of 2 is 32. How we are getting 32, right? So here we have this dimension, right? So if I'll put at the place of x value, if I'll put 2, so what I'll get? I'll multiply this 2 by this equation 2. The second term will be 6 multiplication by 2, and third term will be simply 8, right? If you will equate this value, you will find something. 2 to the 4, 3 the 12, right? So 12 plus 6 to the 12 again. So here we have 12 to the 24, and 24 plus 8 will be 32. So finally we are getting 32 when we are putting the value of x as 2 in this equation, right? So this is the long equation for if you go for manually process. But if you choose the single one, right, single automatic equation, so you will find this one, this simply p of 2 is what? P of 2 is 32. P of 3, if you are supposed to put value 3 at the place of x everywhere in the same equation, in this equation only, right? So you will get value of 53. So you can pass multiple value at a single time, right? Suppose I am going to print this function, copy and print this value, and let's say I'm try to print more values, let's say 4, or let's say p of 6 also. So I'll include 4 and 6 and comma 3. So can you see it's giving respective value 32, 80, 152 and 53. So we have all the values here, and that respective value will be there, right? Now the second part comes, you want to print roots of p, right? Roots of p, how to find roots of p? Here we have -1 or, so how to find roots of p, right? Suppose we have any value, any equation, let's say it's x square plus 2x plus 1, right? So what will be the roots of this equation? Obviously the roots will be x is equal to -1 comma -1. So we have these two values here, right? Now I'm going to initialize one equation which is equivalent to q, or here we have q value, right? So what's your first coefficient here? First coefficient is 1, right? What's the second coefficient? 2. Third coefficient is 1, right? So here you can see x square plus 2x plus 1. Now I want to find the root of this equation. So simply I'll write q dot r. If I run this code, can you see this minus 1 or dot? What is dot here? We have unit value, single unit value. So in single unit value, NumPy is represented by dot operator, right? It's a single value there, right? So we have the array of this value. If you will write simply q, it will show the coefficient of respective values, right? Now we have more functions, like suppose we have print p, and let me print p here. P1 is equal to poly 1d 1 2 3 variable y, and equation with variable y as y, right? This is the polynomial 1d and variable y. So what's the output of this equation? Here we have, instead of 3x square 6x, which was the previous equation, now we have variable as y, right? Sometimes we need time equation, right? So for this time equation, we need t variable. This is the universal truth, some kind. The equation with variable as t for time, I'll be writing that p1 polynomial 1d, and here we have to replace this t. So p1 is what? So, or okay, I'll have p2 is what? Polynomial 1d 1 2 3, right? So okay, so I'll have to print p2 also. Print p2. So here you can see p2 plus 2t plus 3 will be displayed, right? So moving on to our next topic, which is relevant to the integration of polynomial. You guys might have heard with the integration part. So we have solution for this also. So integration function called integ, k is equal to 6. So what is k here? You guys can remember when we have learned this integration part. Here we have integration of anything. Let's say this is from 0 to 1, constant integration, and everything is given by fx with respect to dx. So we are supposed to perform this integration, right? So the output of this integration will be something, some equation, some value plus c, right? So but this c is sometimes called coefficient, constant term, and this constant term is called k here. They are calling k is equal to 6 here as a indefinite integration constant. Here we have that one. So allow me to run this equation. Can you see? For this equation 3x square plus 6x plus 8, we have x cube, which is the integration of this 3x square. Then we have then we have 6x square upon 2. So here we will have 3x square. Then we have 8 for this constant term. We have equation of 8x. And finally, for the constant, we will get k is equal to 6. What will happen in this integration if I won't add this k as a constant term. So let me remove this constant. Let me run term. So by default, it's not showing anything, which means k is equal to 0 in default case. So we will be discussing that part. So this was all about the integration part. Have any query, any question, then we are moving towards the next part, which is the differentiation of polynomial, right? So for this, what we have, for this we have term DAI RIV, that's it, derivative of this one. So p dot derivative, if you run this code, you will find 6x plus x. How we are getting this one? So let me copy, or let me go to the above part. Here we have this value. Let me select this term. Here we have these terms, C, and drag it here, right? So we have this as a equation, right? So what we'll trying to perform? We are trying to get this 3x square plus 6x plus 8, right? So what will be the differentiation here? So here we will have 6x as a first term, right? This is the differentiation of derivative of first term. The derivative of second term would be 6 plus 8 will be 0. So derivative of constant term is 0. So the remaining part here 6x plus 6, right? So here we will obtain 6x plus 6, which is simply the derivative part here, right? Next part we are going to include, we have this marked down. Then we have spatial function where we are calling import scipy dot spatial. So I'm going to import this scipy. Oh, it should be code here. So scipy dot spatial, right? So I have just imported there. So now I'm going to import NumPy as np, and then a is equal to np dot arrange with 1 comma 11, right? And finally a. Oh, it's single a, single r. So here we are distributing 1 to 10, excluding the second term. Inside the arrange function we have 1 to 10, and every value is just having increment value of 1, right? So this is the arrange function, right? So what will happen if you will give the another part? Let me go here. So we will have a is equal to arrange. Let's say I am having 2. So third integer value is 2. So we will have we are skipping 2 values or 1 values in between consecutive numbers, and we will have 1, 3, 5, 7 and so on, right? So here we are having 1, 3, 5, 7 and 1 to 11 we are going to obtain values, right? But we are not interested in these skipping 1. We having only 1 to 11, right? 1 to 11 means 1 to 10 value. It's excluding the second term, right? Now they are going to find this cube root. So what's the cube root here? Let me give it here. Cube root is scipy.spatial.cbrt. This is the cube root of a. So let me run this code. Can you see this cube root of 1 is 1. Cube root of 9 is cube root of 8 is 2. Can you see this is showing 2, which is just spatial of CBRT. So it's inbuilt function inside the spatial method. You won't find anywhere else until unless you do not import this scipy.spatial. You will not find anywhere else this CBRT function. It's just applying the simple function cube root function over each element. That's the closer look at this function here, right? If you are going to include more function inside the same spatial x is equal to 3, we have scipy.spatial, then exponential of 10, then we are going to import this run, right? So what's the exponential of 10 means? 10 raised to power this value. If you write, can you see this 10 raised to power 3? It's a 10 raised to power 3, 10,000. If I'm having 5, so 10 raised to power 5 will be 1 lakh. So can you see 1 lakh value at the output? So here we will find exponential of 10 means 10 raised to power x. Instead of exponential 10, we can import exponential of 2. So I can directly use this spatial dot exponential 2 and this 3. So what would be the output? 2 raised to power 3 will be 8. So can you see 8.0 will be there, right? So here we can have so many other functions inside the spatial. You can go for the official website and you will find the respective value, right? Now similarly we can go for the degree of radian. So what is the degree of radian? Here we have degree, minute and second. So 30 degree, 10 minutes and 50 seconds. So I'm going to convert into the radian. Can you see? It just converted entire degree into the radian. We don't need to write manual function for the same. If you are joining these terms, these simple attributes, arguments, DMS, then you don't have to convert into the don't have to pass into the user defined functions. They have simple values there, right? What about the trigonometry functions? Yes, we have solution for this same also. We have trigonometric functions in degree. Sine of 30 degree, cosine of 30 degree will have cos degree. SIN stand for sine, DG stand for degree. So 30 is 30 degree. TAN for tangent, DG for degree. So let me run this code. You will find respective value for this one. So we will be discussing the detailing part of this spatial function, but as of now we are dealing with the 30 degree and cosine 30 degree and tangent, right? The same functions are available in the math functions also, but sometimes we needing advanced function or advanced values there also. We are having more accuracy in this spatial functions in the scipy, right? So can we go for permutation combination? Yes, we can go for permutation combination. Scipy.spatial.permutation, which is 5p2, right? So we have this 5p2. So what's the 5p2? So we have 5 factorial, right? So what we will, and then in the denominator we will have respective value, right? So what's the what would be the expansion of this 5 factorial? This would be 5 multiplied by 4 multiplied by 3 multiplied by 2 and so on. So 5 4s are 20, 3 2s are 6. So 20 into 6. So we will have 180 in the numerator, right? But we will have denominator also. So what's the denominator here? We will have 3, right? So we will have 3 into 2, right? So 3 into 2 will be cancelled out. So here we have 3 cancelled out by 3, 2 cancelled out by 2, and final output will be 2. So let's cross check with this output. Do we have 5p2 as a 20? Yes, we have that 5p2 as a 20, right? Combination. Next we have combination 5pc2, right? So in the 5c2, if it is 5c2, so we will have the denominator we will have 2 factorial also, right? So what will happen? So we will multiply with 2 again. So I'll cancel out with 2 with 4 here. I'll get 2 here. So 5 2s are 10. So output will be 10 here. Can you see? The 10 will be output. Okay, let me run this code. Here we are getting 10 output, right? So what others we can have? We are going to discuss integration, right? And numerous type of integrations are there. We come out this integration. We have single integration, double integration, triple integration, or multiple integration, and many more, right? So first we are going to import the basic library. Let me convert into the code part here. So we are going to convert scipy.integrate, right? This is the this library used for integration. All right. So for this integration, we will be using lambda function. So we copy this part and then down. So here we will using lambda function in brief, right? So what is this lambda function? Suppose I am having f is equal to lambda and x would be x double asterisk 2, right? So f of 3 would be 9. So I had applied this f. F is kind of lambda function, anonymous user defined function, which is not having any name but functionality only. So here we have x raised to power 2. So 3 raised to power 2 will be 9. Let me change this code, x raised to power x. So it will be 27. So the self powers 3 raised to power 3. So let me pass it as f raised to power 5. So 5 raised to power 5 will be 3125, right? So if you want to check, cross check this value. So here we have 5 asterisk 5 asterisk 5 and asterisk 5. So 5 times 5 multiplication will be 3125, which is the true for the self power function, right? Or you can create lambda function using this multiplication of two numbers. So here we are passing two numbers. Finally, they will jump to the operation part here. So the subsequently we will get 2 multiplication 3. 2 multiplied by 3. So 3 to the 6, we will get 3 to the 6 here, right? We can go for more complex part inside the lambda. So here we have x comma y. So these two terms will be passed into the x plus y whole square. So here we have this one, x raised to power whole square or 3 raised to power 2. So this will be 9, right? So you can create multiple complex functions also, right? Can we have lambda function others? Here we are having scipy integration coordinating, right? So what's the coordinating? So here you can see, here we are using single integration. Quad is used for single integration. So here we are using single integration and f. So x raised to power 3 is the fx. So fx is x cube. And this x cube is going under through this value I. Okay. So let's create this integration part. And here in this integration, we will have this symbol of integration. This will be 1. This will be 2. And here I am getting this f of x with respect to dx, right? And then we are going to create this x square, right? X cube, sorry. Here we have x cube, integration of this one with respect to 1 and 2, and with respect to the limitations are 1 and 2, and then we have dx over here, right? This is the fundamental value, right? So we are getting this 3 and 4.75, two values out of it, right? Can you go for more complex integration? Here we have lambda exponential of this one, and quadratic function will be there, and we will obtaining two functions again, right? This is the single integration. And now we can go for the double integration also. Double integration is using different term. What is the function used for double integration? dbl quad. So what is dbl quad here? Here we have dbl quad, and this lambda function we are passing through, and then lower limit and then upper limit, and then we are having another lambda function, and then another lambda function. We have double integration for the same, and we are going to pass this area value, right? So this was the integration part, and we have other functions. So if you have any query, you can write in comment section, and you are going to cover other functions in the upcoming sessions also. But here we are using this double integration. Let me recap one more time what we have covered till now. In this session, we have covered scipy tutorial. This is all about the scipy functions. More, you can go for basic polynomial integration, linear algebra, interpolation, statistics that are remaining, that are the advanced part of this session. Then we have covered the polynomial, one dimensional, two dimensional, multiplication of polynomial, root of this one, polynomial 1, polynomial 2, integration of this part. Then we had seen the differentiation of this value. A special function includes the range, cube root, exponential of 10, exponential of 2 value, then radian value functions, trigonometry function, sine, cos, tan, and then we have permutation and combination, direct formula, no user defined equations are required. And then we have integration, respective integration functions are there, dedicated functions for single integration, double integration, triple integration, and so on. Then we talk about different issues that have come up since the last session. It includes lambda function in brief, then lambda function for the complex functions, integration part for the same, then integration for the quadratic value, integration accommodate with the lambda value, lambda functions, then we have respective solution for the same. So this was all about the scipy functions. More you can explore by hitting the official website, and you can visit the advanced and complex function from there. This was the all about for this session. Thank you for joining. Thank you once again.